Hello, this is a quick review of simple machines and levers and how to do the math that is involved with levers. This first picture we see is a first class lever. The way we know it's a first class lever is the fulcrum here is right in the middle. The fulcrum is the part that I'm just about to highlight, that part right there. Right in the middle. That's what makes it a fulcrum. Usually you put a load on one side and then you push the force down on the other. So it's kind of like a teeter-totter. The next kind of lever is a second class lever. This kind of lever, the fulcrum's at the end. You lift up on the opposite end right there. It kind of works like a wheelbarrow. The load goes in the middle. Okay, so to review, let's keep going actually. We'll go to the third class lever. For third class lever, you'll notice so far it looks just like a second class lever. The fulcrum's at the end. Except now, if you notice, the load has now changed positions. It's on the whole opposite end, and then we're pushing up in the middle. So looking again at first and second class levers, the only thing that happens, the only difference, is the load and where you're pushing up or pulling up is changing positions. Alright, let's do a few examples of the math. Alright, so how much muscle or force is needed to lift the rock? Lift this rock. Okay, so we've got our fulcrum in the middle there. So you should be looking at this right now and be able to identify what kind of lever is this. Okay, this is a first class lever because the fulcrum is in the middle. So let's add our rock here. Let's say that rock is pressing down towards the earth with 30 newtons of force. And we got this muscle man on the other end. He's going to push down. How much force is it going to take him to press this teeter-totter down? Well, we got to review the formula. Force times distance on one side is going to be equal to force times distance on the other. So if we got our force here, force times distance right there. So notice we measure from the middle out to our force, or from our fulcrum to our force for the one side. And then for the opposite side, we got our force on the end. Okay, there's our force times our distance. We're also going to measure from the fulcrum to the middle. On every single one of these examples, you will always measure from the fulcrum out to your force. Alright, so let's measure these out. Throw my handy dandy ruler on here real quick. There you go. So the one side, this is the orange side. This is the measurement that's going to go with the 30 newtons. It's really, really, really important that you keep the 30 newtons together with that side's measurement or distance. So we got, looks to me to be about 46.5 millimeters. We're always going to measure in millimeters. And what goes with the 46.5 millimeters will be the 30 newtons of force. Okay, we multiply those together. On the opposite side, we have force times distance, so we got to measure that. If we measure right out from the fulcrum to where the arrow is, that looks like that is, let's see what I wrote down, about 35 millimeters, and that goes with what force? Well, we don't know, so that stays the variable, that's the F. So F times 35. Now it's just a matter of algebra. We're going to multiply the orange side together. I'm going to go fairly quick through this part. We get 1395. So we still have F times 35 on the other side. Divide both sides by 35 and we get the force equals 39.9. And then what would the label be? For the label, we have to use the same label as the force in the picture. So we have 30 newtons right there. So that means this has to be 39.9 newtons. Alright, next slide. How much muscle or mass will be needed to lift a load in the wheelbarrow? Okay, so here's our load. I marked right on the one end over here. This is my fulcrum. Okay, this is where I'm going to apply force to lift up the load. And there's my load. So it looks like I have a load of about 773 grams. So we need to put our ruler on this and figure a few things out. One thing to notice that I told you on the first example was always measure from the fulcrum to the force. Okay? Every single time you have to go from the fulcrum to the force, and I will show you what I mean. So we got force times distance equals force times distance, same formula. The force on the one side, notice it's all in green, is 773, and what distance goes with that force? Well, that would be the distance highlighted above, which would be about 20 millimeters. Okay, that's really important that you put the 20 has to go with the 773 on the same side of the equation. So, on the other side, this is where people sometimes mess up. We don't know the force, so we're just going to write force times. What do we measure to know the distance from that side? Look at my clue at the bottom of the page. It says always measure from the fulcrum to the force. So we have to go from the fulcrum all the way out to the force. And we have to measure the whole distance. It actually overlaps with our last measurement. And we get about 47.5. So let's run through the algebra. 773 times 20 will give us about 1546. We still have F times 47.5 on the other side. Divide both sides by 47.5. And we get a force of, about 325.5. Now what's the label? Once again, we got to look up above. What was our label for our force originally? And it's right there. It's grams, so this has to be grams. Okay, this was an example of a second class lever, like a wheelbarrow. Last example. Okay, so here we go. We're going to pretend like this is kind of like a wheelbarrow here. We got the fulcrum down at the end, the blue circle, and we have our load now on the full opposite end. So this is different from our second class one, and we're going to push up in the middle to try to lift that object. So how do we set it up? We're going to do force. Looks like we have 65 newtons, sorry, for the weight of that object at the end of the lever. So we know it's going to be force times distance equals force times distance. So right here what I highlighted, those are the two objects that are going to go together. Okay, the distance there and our question mark, our variable, our force that we do not know. Okay, so it's going to be force times distance equals force times distance on the blue side. We don't know the force, so we say F. The distance looks like it's about 19. On the other side, you got 65 newtons. What distance goes with it? Remember my clue from the last side. What distance would go with that? Take a second, try to answer that question. Okay, and it would be about 50. We have to go the whole distance, what's highlighted in green, from the fulcrum all the way back to the force. And then we do the math. Okay, we get 3250 on the one side, and we still have force times 19 on the other side. Divide both sides by 19, and we get a force of 171 newtons. And remember, the label has to go with the label which is on the force above. It says 65 newtons right there, so then our label has to be newtons. Good luck on the concept check.